So hi guys, so now for today's video, we're doing the chapter 11 rather, chapter 10, chapter 11 video. So let's start the video. Chapter 11, build a small network. In this section and objective, you'll learn network design, network security, basic network performance, and network troubleshooting. Network design. Small network topologies. A majority of businesses are small and typically requires a small networks consisting of a single router with one or more switches and possibly one or more wireless access points. The business might also have IP phones. Managing all networks is similar to managing a large network. Device selection for a small network. Regardless the size of all networks, require planning and design to ensure that all requirements, cost factors, and deployment options are considered. Cost, speed, and types of ports, interface, expandability, operating system features, and services. IP addressing for a small network. IP addressing space must be planned when implementing a small network. All hosts within an internetwork must have a unique address. Different types of device will factor into IP design, including end devices for users, servers, and peripheral devices. Different devices types. Hosts are accessible from the internet. Intermediary devices. Planning and documenting the IP addressing scheme helps administrators track device types. For example, if all servers are assigned a host address in the range of 50 to 100, it will be easier to identify. Redundancy in a small network. Reliability is another important element of network design. A network failure can be costly. The figure to the left represents a data center. There are four types of redundancy. In this figure, redundant servers, redundant links, redundant switches, and redundant routers. A server link switch or router could fail and the network would continue to function. Traffic management. The types of traffic and how they should be handled should be considered and prioritized in the network design. Routers and switches in a small network should be configured to support real-time traffic such as voice and video. Voice high priority, video high priority, SMTP medium priority, instant messaging normal priority, and FTP low priority. Network traffic should be classified according to priority in order to enhance productivity of employees and minimize network downtime. There are two forms of software programs or processes that provide access to the network. Network application layer services. Common protocols, DNS, DHCP server. In most network professionals work with network protocols which support the applications and services used by employees in a network. Types of messages, syntax of the messages, meaning of information fields, how messages are sent, and expected response interaction with the next lower layer. Voice and video application. Businesses today are increasingly using IP telephony, and streaming media to communicate with customers and business partners. A network administrator must ensure that the network can support these applications and services, including a supporting infrastructure with inappropriate switches and cabling. Small network growth. To scale a network, the following are required: network documentation, device inventory, budget, and traffic analysis. Protocol analysis. You need to determine traffic flow patterns, capture traffic during peak utilization, times perform the capture on different network segments since some traffic will be local to particular segment. Employee network utilization. A network administration has the ability to obtain in in-person IP snapshots of employee application utilization. Over this information can help network administrator adjust network resource necessary. These snapshots typically include OS and OS version, non-network applications, network applications, CPU utilization, drive utilization, and RAM utilization. Next topic is the network security. Types of threats. Network information threat, thief, data loss and manipulation, identity thief, and disruption of service. Physical security. The physical security has four classes that must be dealt with: hardware threats, environmental threats, electrical threats, and maintenance threats. Types of vulnerabilities. Types of vulnerabilities is TCP or IP protocol weakness, operating system weakness, and network of pavement system. The three primary vulnerability that can lead various attacks is technological, configuration, and security policy. Types of malware. Viruses, worms, Trojan horses. Reconnaissance attack. Reconnaissance attack, access attacks, and denial service. Access attacks has password attacks, trust exploitation, port redirection, and man in the middle. Denial of the service attack, or DOS, ping of death and sync flood. DDoS and SMARF attack. Backup, upgrade, update, and patch. Keeping up to date with the latest development is a critical part of network security and defending against network attacks. As new malware is released, enterprises need to keep current with the latest version of the antivirus software. The most effective way to mitigate worm or other attack is to download security updates from the operating system vendor and install the patches system. Authentication, authorization, and accounting. AA is used to control who is permitted to access a network, what they can do while they are there, and what did they do when they were accessing the network. Firewalls. Firewalls are one of the most effective security tools available. Wala din eh. Hindi ka na-search din eh. Ba't nawala doon? Itanong mo kay mama. Stateful packet inspection. Endpoint security. An endpoint Our host is an individual computer system or device that acts a network client. Common endpoints include laptops, desktops, servers, smartphones, and tablets. A company must have a well-documented policy in place that employees must forward since securing endpoint device is on the most challenging jobs of a network administrator. Device security overview. Passwords. Basic security practices like on the chapter 2 service password encryption, just like that. Next topic is basic network performance. Interpreting ping results. The use of ping command is a very effective method to test for network connectivity to a particular host. Server device. It is important first step in troubleshooting a network failure. The ping command uses the Internet Control Message Protocol and verifies layer 3 connectivity. A ping issued from the iOS such as a Cisco router and yield several indicators. The most common are the exclamation point and the period and U. Extended ping. The extended ping this mode is entered by typing ping is privileged exec mode without a destination IP address. Just type ping, press enter. Network baseline. One method that can be used is to copy and paste the result from a ping trace or other relevant commands into a text file. Interpreting trace message. Extended trace route. Command the ipconfig command. ipconfig or all command can be used to view the MAC address as well as other important details regarding the layer tracing. The ARP command. The IPv4 address, physical address, and the type of addressing is displayed for each device. The show CDP neighbors command. The Cisco Discovery Protocol is Cisco proprietary protocol that runs at the data link layer that allows adjacent devices to learn about each other, even without the layer 3 connectivity. The show IP interface brief command. The debug command. iOS debug command entered in privileged exec mode allows the administrator to display this message in real time for analysis. The terminal monitor command. Connections to grant access to the iOS command line interface can be established locally or remotely. Debugging long messages are sent to the console by default and not to virtual lines. 11. For the last part, network troubleshooting. Basic troubleshooting approaches. Technicians must be able to analyze the cause of the network problem before they can resolve the issue. Resolve or escalate. In some cases, it may be possible to resolve the network problem immediately and may need to be escalated if it requires manager's decision. Verify and monitor solution. There are tools to help with the troubleshooting and verification, such as pin trace route and show IP initial brief. Duplex operation. In duplex operation, It refers to the direction of the data transmission between two devices such as a router and a switch. Half duplex and full duplex. Duplex mismatch. Duplex mismatch issues are difficult to troubleshoot since the communication between devices still occurs but is usually much slower. Ping may not detect the problem. A ping could be successful even though there is a mismatch. IP addressing issues on iOS device. IP addressing issues on end device. Use the ipconfig command to verify the IP address assigned to a Windows-based default gateway issues. Use the ipconfig command to verify the default gateway on a Windows-based computer. Troubleshooting DNS issues. Use ipconfig or all to obtain DNS server packet tracer issue. So that's all for the chapter 11. I hope you understand my recording. Let's see each other again next time. Bye.